Yeah. Thank you, far too kind.
Yeah.
Ready?
Let's go.
Can I get an encore? Do you want more? Cook and roll with the Brooklyn boys. So for one last time, I need y'all to roll. Yeah. Now what are you for? After me, there should be no more. So for one last time, make some noise.
When I get it,
Who you know fresher than Ho? Riddle me that. The rest of y'all know where I'm lyrically at. Can none of y'all mirror me back? Yeah, hear me rap, it's like hand G rapping his
F equals MA. What does that mean? It means force equals mass times acceleration. Now, what is mass? Mass is the amount of weight of an object, or how heavy it is, or the object in general. Force is the amount of force that you apply. It's something that you apply to make something move in the wanted direction.
What we see here is a balanced force, but when I join in, it's going to be unbalanced.
Oh, really? Got you. I'm not even trying.
I got a condo in Manhattan. Baby girl, what's happening? On that get to clapping. Go pop it for a plan. Pop it for me. Turn around and drop it for a plan. Drop it for me. I'll rent a beach house in Miami. Wake up with no jammies. Lobster tail for dinner. Julio served that scampi. You got it if you want it. Got it if you want it. Said you got it if you want it. Take my wallet if you want it now. Jump in the Cadillac. Girl, let's put some miles on it. Anything you want, just to put a smile on it. You deserve it, baby. You deserve it all.
And we're going to be talking about the Newton's law of inertia. The definition of inertia is the resistance of any physical object to any change in its state of motion, including the changes to its speed, direction of state, or rest. And Javier is going to demonstrate.
This is a balanced force. I am not moving, and the table is not moving. Yo, what up? It's your boy Javi.
Is Arthur right here? It's according to my calculations, it's Chino here, you know what I'm saying? So we're going to teach you about chemical equation.
Hello, my name is Javier. I'm going to tell you a little bit about coefficients, subscripts, and elements. Okay, so we'll start off with the basic. What is an element? Well, an element is actually, it composes of one pure atom, which is the building blocks of everything we know of. Some things are known as compounds, which are a mixture of elements, but they're not pure like elements are. Now, here we have an example of helium. Helium is an element because it only has one kind of atom, which is helium. So, here is what a coefficient. What's a coefficient? Well, coefficients are numbers. There's two numbers, there's two kinds of numbers in a chemical equation. There's a subscript and a coefficient. This is a coefficient, which means this is the amount of molecules in total that you have to see and find out how many there are. Like here, CO, this is 2. So this, you have to multiply this by that. You always have to multiply the certain amount of atoms or elements by this number. Here we have H2O. This is the subscript. Over here, we will have 4He2, for helium-2. This is the subscript. This is the coefficient. Now, you have helium here, which is 2. And then you have to multiply this by this. Usually, all the time you have to do that. So it's helium 4 times 2 is what? 8, which is what we have up here. We would have 8 helium atoms. And this is pretty much the basics of counting atoms with the coefficient and the subscript and elements.
Yo, Yo, it's Chino here. I'm about to drop some science and tell you how it is and how chemical reaction happens. Alright, well, a reaction in which a chemical change occurs is called a chemical reaction. And a chemical reaction is the reactants combine together to form completely new substances. The substance is called the products. When atoms, bonds, valence electrons may be transferred from an atom to another, or they may be shared between the atoms. A chemical bond is a force of attraction that holds atoms together as a result of a rearrangement of electrons between them. The number of electrons the atoms of a particle element may lose, gain, or share determines the element's reactivity.
I'm gonna show you today, it's an action-reaction example, as in once a force is applied to a non-moving object, the force is gonna be put back, but in an unbalanced but equal force. As an example today, Karina, as you can see, it bounced back. So, that's why. That's why.
Okay, guys, we have some rare elements here. We have iron, we have xanthium, and oblivium. Okay, I'm gonna try to make a speed enhancing formula. Okay, we're gonna call it chemical X. Okay, let's begin. Whoa. Now we need the iron. This is gonna explode. Watch it out, guys. Now we need the final. We need the final chemical. This is polymesium, the most dangerous and explosive chemical on Earth. It's radioactive too. I don't know why. I don't have grounds, but we need to mix these. Make chemical X. It's changing. It's changing.
It might seem crazy what I'm about to say.
1, 2, 3.
Sunshine, she's here. You can take a break. I'm a hot.
Go.
Oh, what's up?
Start
I
off,
am
Lee.
Luis.
With the air, like I don't care, baby, by the way.
I'm gonna show you. Oh, I just died.
Keep going. I'll just edit it.
Because I'm happy. Clap along if you feel like a room without a roof. Because I'm
The wall, once the truck hit the wall, the force bounced back. And that's an actual reaction, as in equal force.
That didn't come out right.
because I'm happy. Clap along if you feel like a room without a roof. Because I'm
Yo, what up? It's your boy Javi.
Oh yeah, what's up? I'm Arthur.
I'm Chino. Which
We're
I don't
going
know.
to teach you a little bit about chemical equations.
Okay, that's enough.
Alright,